introduction. Thank you very much. I love presenting on day 3 of conferences because it's the people who really care that actually turn up. Everybody else who doesn't really give a shit at this point is drunk, hungover, or probably left already. So thank you for being here, and I promise to leave you with something that will be hopefully informative and interesting as we get to the end of the session. What I want to try and do is give you guys a reason to continue to care about ZK. You already care enough to be here for this part of the session, but when you leave, I'd like you to leave with an understanding of why ZK matters not just for Web3, but for humanity in general, and that zero knowledge is a technology that actually solves a bunch of non-Web3 problems that we have a huge opportunity in being able to enable. It's also a mass adoption machine for Web3, and I'll get into why. Click. And there's an important fundamental point behind this that sits under everything, which is, with zero knowledge, we're able to send proofs of data, not the sensitive data itself. Right? This sounds like an obvious thing, but I'll point out why it is completely normalized that this is not the way we do things today and why we need to change it. So data, broadly speaking, is a bit like a leaky bucket. We could keep pouring data in, keep pouring information into the internet, into our applications, through our phones, through our devices, but somehow it always manages to leak out and we lose control of what we've got and where. Right? Our data today is not our own, it is not controlled, it is not within our control most of the time. And you've seen a million charts like this, I'm sure, of how many billions of terabytes of data is produced every second on different applications. This is not the slide to be taking a photograph of, but I will cue you on the ones that you do need to take a photograph of, so keep your phones ready. I can't believe I'm saying that at a conference, but for those people who have phones, get ready for that. And it's only going to get bigger and more significant as we start seeing a significant growth in bots, devices, autonomous vehicles, autonomous sensors. We are only going to see more bots and more data and more identity and more sensitive information being passed around the internet as we know it. And that's not a good thing. Here's how apps work today. Many of you, I'm sure, are technical, so this may not be a surprise, but for those who are not, at least let me baseline. This is how applications work today. A user or a company or an entity on the left-hand side sends encrypted data packets to a third party over the internet. This is a radical simplification, I know, but broadly speaking, we send data packets over the encrypted web to a third party. This is how Web 2 works today. We're not going to talk about why encrypted data on the internet is necessarily a bad thing. We're not going to challenge that encryption on the internet is necessarily flawed today, but we are in the quantum era as we know it, and encryption and putting encrypted things on chain or over the internet is not necessarily a guaranteed safety for the rest of our lives. So that's also something we have to challenge. So we're already normalized in sharing more data than we necessarily need to. How many of you in the room have sent a photocopy of your passport, your driver's license, your address details, your date of birth, any sensitive personally identifiable information over the internet in the last month? Literally everybody. Amazing. So we have completely normal, and that doesn't scare any of you, right? This is normal. What is also normal is that in Web 3, we're sending all of our transactions and all of our data on-chain, theoretically visible and correlatable to anybody. So you guys are probably either very, very comfortable with your positions in security, or you have nothing to hide. Well done you. If you do have something to hide, I've got more for you later. At the moment, utility is coming at the cost of your data, and we don't think that's necessarily the right way to orchestrate applications. There's no equity in that solution. And let's also not make villains of the guys who are trying to serve you at the same time. Okay, yes, there are businesses who monetize data and who use your data for their profit model, that's fine. But for somebody who's just trying to buy a pair of shoes over the internet, they don't want your data, they just want to sell you shoes. And at the moment, there's a cost of storing that data, processing that data, governing that data, and they have a whole infrastructure of people around managing your sensitive data and trying to make sure that it doesn't leak out onto the internet for other people to use nefariously. And how often do you hear about hacks of centralized servers that have been connected to the internet? Literally all the time. And so this isn't a great model for companies or e-commerce or third parties either. They don't want this. You don't want this. Nobody wants this. Not that TV show from Netflix, but also a good show. Recommend you watch it. So we need to liberate our data. And a few years ago, we came up with an idea of how we do that. Blockchains. And so we thought, okay, blockchains are a way that we give back control. We give back sovereignty to individuals, to you, Whoever it is that's transacting with third parties, it could be a bank, it could be an application, it could be a conglomerate, it could be peer-to-peer, it could be anything. We will use blockchain, encryption, and self-sovereignty and wallets to bring back control. Blockchains are decentralized. They enable self-custody. They are censor-resistant. Can't be taken down, can't be manipulated. All really good things. Also blockchains. Very, very transparent. Any data that you're putting out there on Ethereum or most EVM chains today will have correlatable data and metadata that you can then you can track with not an awful lot of effort and maybe a super user on Nansen. You can get an awful lot of information about an individual very, very quickly. And how many of you have your first name and second name as your .ens address? Don't put your hands up. People are watching. But if you do, or if you have any sort of human-readable, correlatable name on your ENS address today, there's a very, very good chance that people can find you and know how much crypto you have and figure out which conferences you're attending. And that's not a good thing. And we've tried to do certain things with privacy and privacy chains. We've seen privacy coins. We've seen Tornado Cash. And unfortunately, the rest of the world's infrastructure doesn't like the idea of privacy as blockchains have implemented it at this point in time. Because full privacy, dark, invisible to all, is not seen as compliant, is not seen as this is the way we would like the world to engage with privacy. And there is another way. But full privacy change at this point in time will probably get you jail time. So that's not a great architecture either. So this is one of those pictures that you can take. I warned you there would be. And so we have the Web3 model of how we do decentralized applications. We send the user, controls their data, sends it to a smart contract. That smart contract puts that data on-chain, typically very transparently, and is starting to create correlatable metadata about you. And also, because not all decentralized applications today are on-chain and fully decentralized, you're probably also seeing some sensitive data also leak out to the dApp operators at the same time, because we haven't shielded everything. So we've created a new problem, and we haven't really solved the original one either. So ultimately, these are two wallets. On the left, Vitalik. On the right, Justin Sun. Visible, doxed, public, known to everybody who wants to go check it out. Right? This is interesting. It's an interesting observation. Essentially, what we're doing is we're making your bank account details, your browser history, your voting history publicly available on-chain for everybody to go and check out. You guys might be risk accepting that that's okay, you've got nothing to hide, but the rest of the internet is not coming to Web3 based entirely on this. This is the Web3 scaling problem that ZK solves. Roll-ups and number of transactions per second and cross-chain interoperability, all good primitives. But the Web3 scaling problem that we have to get past is that companies, individuals, mass adoption does not want this, and we have to do better. And ZK and zero-knowledge smart contracts, zero-knowledge proofs are the ways to enable this. All of these companies on the left, in the last 5-6 years, have considered an application on blockchain technology. That could be intercompany settlement, it could be finance, it could be joint venture agreements, it could be trade finance, it could be supply chain. All those Web3 blockchain use cases that enterprises were getting really excited about, that we've now kind of bucketed under a broad category of real-world assets, which actually is shorthand for tokenization of things. All these guys thought, Web3, this is a brilliant idea. Decentralization, yes. Infrastructure that we can trust. Technology that can't be evil, that's not owned by anybody or a third party that I'm going to get locked into. That's a really good idea. We really like that. They got through the idea of research. Yep, we like Web3. We got into a pilot. Maybe we used Hyperledger Fabric. That sounds sexy. And then they got into some form of development. And then they got to the point that says, let's put it on chain. And somebody in the IT organization or the chief information security officer said, so you're going to put our operating data, our financial data, our interactions with our third parties and our suppliers on a public internet for everybody to see all of the time. Yes, forever. Blockchains are available forever. They can't be taken down. No, we're not going to do that. Some guys got into production. All these other Fortune 500 companies, that's mass adoption, by the way. These guys on the left didn't get there because of the single problem that you guys are risk accepting your way into today, that everything you do on blockchain is visible for everybody all the time forever. And also because blockchains are immutable, anything that's been encrypted on chain could be decrypted later on. That's not a today problem, but Moore's law says in 5 or 10 years' time, that could be a tomorrow problem. And so you may be safe now, but you might not be safe later. So can we do better? Can we not put encrypted data on chain? That's what we're arguing for. And metadata, still, it may not be the transaction data. Some blockchains, some applications are starting to shield the transaction data, maybe starting to shield maybe some parts of it. But any EVM chain is typically going to create some degree of metadata, which maybe you don't see all of the information, but you can start putting different parts of it together. This is metadata. And when you take different parts of metadata together, the address, a timestamp, maybe the interactions with a contract, you start being able to correlate what could be represented, if this was a large organization, production throughput, shipment frequency, carbon output. If you're tracking carbon credits are a proxy for industrial output. And so the more credits you're buying at certain times, the more you're going to make visible your operational data or your operational routines. It may sound trivial, it's like, oh, they'll never be able to do anything with that. We are in the age of AI and machine learning, where correlation of data and drawing conclusions can be done in microseconds. It may not appear to us as our human brains, but machine learning can do a hell of a lot with on-chain data very quickly. And so again, I'm not saying that Web3 is evil, I'm not saying dApps are bad, and I'm not hating on Ethereum, but I'm saying we can do better. And we must do better if we actually want mass adoption of our technology. So, here's how we do it. This is another one of those photographs that you want to be taking. Data protecting decentralized applications with selective disclosure. On the client side, on the user side, we generate a proof of something. Our identity, that we hold a particular token, that we have a certain balance, that we are liquid, that we have reserves, whatever it could be. This could be a DAO, this could be you, this could be Starbucks. We create a proof that something is true. We share that to a smart contract, and that data can be made transparent, visible, public for all, like Ethereum is today, or it can be shielded and made intransparent up until the point where somebody asks for selective disclosure, asks for somebody to share that information. That power remains with the user. And this is the important part, right? We keep it private until it's not. We keep it secure. We have our own ledger on the client side. And if you need to selectively disclose some information to a regulator, to a third party, to your accountant, that's under your control. It's not fully private all the time with no controls. It's not fully public all the time with no controls. It is programmable privacy. And this is the ZK application, the ZK capability that is going to get us to mass adoption. And at that point, if we can get to a decentralized application, we have the ability for the company or the third party you're transacting with to know nothing about you, to have no metadata, to have no data governance requirements, to have no compliance requirements. They just want to sell you shoes. And so they can just send you shoes. So some principles of data protecting apps. Data remains with the owner. It never leaves the client side. It never leaves the phone, never leaves the server, whether it's on-premise, device, cloud. Privacy is a spectrum. Right? The guys earlier on this morning were talking about TEEs. You also have multi-party computation. You have fully homomorphic encryption. There is going to be a spectrum of applications from fully private all the time and no requirements for compliance to compliance-related privacy-preserving apps to fully transparent Ethereum forever. Somewhere on that spectrum, all the apps in the world live. But if we want to get to mass adoption, we need to be over to that left-hand side. And yes, there's going to be cloud-based data that we can have slightly lower security and privacy requirements on. We may use third parties to store data. We may use third parties for processing or acceleration. And for some people and for a lot of people, that's going to be okay. But for a very large number, it won't be. And that's exactly why we need ZK technology like Midnight and others. Programmable shielding. It cannot be all or nothing. There has to be a middle ground because developers need to compose and build something that is different depending on different regulations, different jurisdictions, different industry applications. We need selective disclosure because that's how we gain compliance. That's how we don't have governments putting our developers in jail. And ultimately, compliance is a good thing. Regulation is necessary. How many people in blockchain have said over the last few years, we need more regulation? It's a good thing, and it's the natural way of life. It's the way industries are constructed. It's how finance works. If we can't get on board with the idea that regulation exists and we need to be compliant with it, we are not going to get to mass adoption. Same story. So as I said before, we need to get around the idea of sharing proofs of data, not the data itself. And so, final thought on whether you genuinely should care about this sorts of thing. Right? I've told you why sending proofs of data is better than sending sensitive data, how we can build a better internet and better applications using zero knowledge instead of the current normalized architecture for sending sensitive data to everybody all the time. 5 years from now, what type of world do you think we're going to live in? Do you think we're going to see more or less proliferation of data? More or less automation, where smart contracts can intermediate, but where sensitive data is still flowing? Do we think we're going to see more or less data oligopolies that are going to put pressure on the equitability of society, the internet, and applications? And do we like that idea? And do we see a world where there's more or less trust over the next 5 years, sorry? I guess it depends on your outlook for the next US election to some extent. But more broadly, have a think about how those things stack up and what type of applications we need to be building as a result. This is the final slide you need to take a picture of because this is how you find us. We've got content specific to Midnight around data protecting applications, the architecture, how we build a better internet. You can find our socials there, you can find our Twitter there, you can find our Discord there if you want to go and talk to our developer relations team who are building applications and helping others to rewire the internet using zero knowledge proofs. Thank you for listening, and I hope that was helpful.